5 is about solving radical equations. These are equations with square roots in them. And the way we get rid of a square root is by squaring both sides. So for example, if to have solve root x equals a, we square both sides. And the square of a square root is b if b is at least 0. So root x minus equals a means that you get x equals a squared. However, the problem is that you can square both sides and get a valid equation, but it doesn't necessarily work in reverse. -1 squared is 1 squared, yet -1 does not equal 1. So this method of squaring both sides might create solutions that didn't exist before. These are called spurious or extraneous solutions. And so for radical equations, you'll want to check all solutions once you get them. So for example, here we have root of x minus 1 equals 2. Square both sides. X minus 1 is 2 squared. X minus 1 is 4. Add 1 to both sides. X equals 5. Now if you check that, put a 5 in here. The left side is root of 5 minus 1. That's root 4. That's 2, which equals the right side. So it checks. X equals 5 is a valid solution. Here we have root y equals -3. Ooh, watch out. A square root is always at least 0, but here I'm claiming it's less than 0. So we're already in trouble. If we square both sides, we get y equals -3 squared, so y equals 9. But if you plug it in, the left side, you get root of 9, which is 3, which is not -3. So this equation has no solution. And that's the answer to the question, what's the solution? There is. The answer is there is none. So for these problems, it's prudent to check all solutions that you get. Oh, here we go. All right, here we go. Solve root y equals 12. Well, square both sides. Y equals 12 squared. Y equals 144. Now if you plug it in, root 144 does equal 12, so it checks. So that's the solution, y equals 144. Here we have root 2a equals 4. Square both sides, you get 2a equals 4 squared. So 2a equals 16, and dividing by 2, a equals 16 halves. So a equals 8. If you can check this by plugging it in. Put 8 in here. Root of 2 times 8 is root 16, which does indeed equal 4. So a equals 8 is the solution. The solution. Here we have root of 5 minus t equals 10. Square both sides. 5 minus t equals 10 squared. 5 minus t equals 100. So subtracting 5, you get negative t equals 100 minus 5. So negative t equals 95. So making minus of both sides, you get t equals -95. Now if you plug it in, -95 for t, the left side becomes root of 5 minus -95. That's root of 100, which is 10. It checks, so the solution is t equals -95. We have root of 4m squared plus 6m plus 6 equals -2m. All right, square both sides. Left side is 4m squared plus 6m plus 6. Right side is the square of -2m. That comes out to 4m squared. 4m squared plus 6m plus 6 equals 4m squared. Now if you cancel 4m squared from both sides, you get 6m plus 6 equals 0. And okay, transpose the 6. 6m equals -6. Divide by 6, m equals -1. Now, okay, we need to check that solution. Plug in m equals -1 into the left side. You get 4 times -1 squared plus 6 times -1 plus 6. That's 4 minus 6 plus 6 is root 4 is 2. Check. That's a 2. And if you plug in -1 into the right side, you get negative twice -1, which is a 2. Check. These equal each other, so m equals -1 is the solution to this equation. Here we have b equals root of 5b plus 1, that minus 1. Now, it won't do to just square both sides, because when you square a binomial, a difference, you get this squared Look at this square root. You'll also get minus twice the difference, so that it'd still be a square root sign. That will not serve the purpose. However, what we do is we want to isolate the square root sign. We'll do that by adding 1 to both sides of the equation. And we get the equation b plus 1 equals root of 5b plus 1. Now we can get rid of the square root by squaring both sides. When you do that, you get the square of b plus 1 equals 5b plus 1. b plus 1 squared expands to b squared plus 2b plus 1. That equals 5b plus 1. Transpose the 5b plus 1. Get b squared plus 2b plus 1 equals negative 5b minus 1 equals 0. 1's cancel. 2b minus 5b is negative 3b. So b squared minus 3b equals 0. Factor out of b. b times b minus 3 equals 0. One of these factors must be 0. Either b equals 0 or b minus 3 is 0, which means that b is 3. So b is 0 or b is 3. Now you'll have to check both solutions. Plugging in 0 into the equation, the left side would be 0. The right side is 5 times root of 5 times 0 minus 1. That's root 1 minus 1, which is 1 minus 1, which is 0. So these equal and they check. B can be 0. Check b equals 3. The left side would be 3. The right side will be 5 root 3 plus 1, that minus 1. That's root 15 minus 1, that minus 1. That's root 16 minus a 1. That's 4 minus 1, which is a 3. These are equal, so b equals 3 also checks. So b equals 0 or 3 for this equation. Here we're going to get 2 solutions, but one won't work. Y equals 9 plus root of y minus 3. Again, we move the 9 to the left so as to isolate the square root. Y minus 9 equals root of y minus 3. Square both sides. Y minus 9 squared equals y minus 3. Expand this side. Y squared minus 18y plus, oh, sorry, this is an 81. Sorry about the legibility. Here it is. Equals y minus 3. Subtract y from both sides, add 3 to both sides. Y squared minus 18y plus 81 minus y plus 3 equals 0. All right, minus 18y minus y is minus a 19y. 81 plus 3 is 84. So y squared minus 19y plus 84 equals 0. Now, okay, I skip a whole table search here for, because we've seen this before, but we get to the cut to the chase and we get that y minus 12 times y minus 7 equals 0. It makes sense because minus 12y minus 17y minus 7y is minus 19y, and minus 12 times minus 7 is 84. So there you have it. This product equals 0, so either y minus 12 is 0 or y minus 7 is 0. If y minus 12 is 0, then y is 12. If y minus 7 is 0, then y is 7. Two possible solutions. We have 2 possible solutions, 12 or 7. We need to check both. Check y equals 12. The left side is 12. The right side is 9 plus root of 12 minus 3. 12 minus 3 is 9. That's y, 9 plus root 9. Root 9 is 3. So we have 9 plus 3, which is 12. These equal, and so 12 checks out. Now let's try y equals 7. If y equals 7, the left side is 7. And the right side is 9 plus root of 7 minus 3. That's 9 plus root 4. That's 9 plus 2 is 11. These do not match. So 7 is an extraneous or spurious root. Now, if this had been a y minus 2, you would have gotten a 7. It wasn't, so there we are. So y is 12. You can, if you mention 7 at all, mention that it's an extraneous root. All right, here we go. Here we have root of 24 plus 10n, that minus n equals 4. To isolate the square root, let's add n to both sides. To get root of 24 plus 10n equals n plus 4. Now square both sides, and you get 24 plus 10n equals the square of n plus 4. This right side expands to n squared plus 8n plus 16. Subtract 24 and plus 10n from both sides. You get 0 equals n squared plus 8 plus 16 minus 24 minus 10n. After some simplifying, combining like terms, you get 0 equals n squared minus 2n minus 8. And after a short search through factors, this factors into 0 equals n minus 4 times n plus 2. So one of these factors equals 0, which means either n equals 4 or n equals negative 2. So these are two possible solutions. We need to check both of them. Check n equals 4, plug in 4 in here. Left side is root of 24 plus 10 times 4 minus a 4. 24 plus 40, this is root 64 minus a 4. Root 64 is 8. So 8 minus 4 does indeed equal 4. So n equals 4 works. Check n equals negative 2. Plug in negative 2 here and here. 24 plus 10 times negative 2, all that minus a negative 2. So here is 24 minus 20, which is root 4. Minus the negative 2 is plus 2, plus 2. Root 4 plus 2. Root 4 is 2, so you get 2 plus 2, which is 4. So both check. So n equals 4 or n equals negative 2. There. This one, 6 plus root m minus m equals 0. We'll isolate the root m by adding m to both sides and subtracting 6 from both sides. So root m equals m minus 6. Square both sides, and get root m squared is m equals the square of m minus 6. So this expands to m equals m squared minus 12m plus 36. Subtract the m from both sides, and you get 0 equals minus 13m plus 36. After a short search through the factors of 36, this expression on the right factors into m minus 4 times m minus 9, which equals 0. So product equals 0. One of these factors is 0. M minus 4 is 0, or m minus 9 is 0. This means m equals 4 or m equals 9. Okay, we start by checking m equals 4. 6 plus root 4 minus 4, that's 6 plus 2 minus 4 is 8 minus 4, which is 4, which is not 0, so no go. Check m equals 9, 6 plus root 9 minus 9, that's 6 plus 3 minus 9, that does equal 0, check. So the solution is m equals 9, 4 is an extraneous root. Okay, this one is actually a word problem where we have some expression s equals 1.45 root r, and s is 65. I think it's a highway speed problem. What is r to the nearest unit? Well, okay, put these together. 1.45 root r equals 65. So dividing by 1.45, you get root r equals 65 over 1.45. Square both sides. R is the square of 65 over 1.45. And after a bit of calculation, it rounds to about 2010. All right, I do believe we're done. All right, then.